This artificial blowhole is designed to convert wave energy into electricity. It's called the UniWave 200, and it just completed a one-year test off the coast of King Island, Australia. We talked to the CEO of Waveswell Energy, the company behind this technology, to get an update on how the UniWave 200 performed, what lessons they learned, and what comes next. Let's get into it. The UniWave 200 harvests wave energy by mimicking a naturally occurring phenomenon, the blowhole. In a natural blowhole, air in a contained space, such as a cave, is compressed by rising waves, which sometimes causes a blast of seawater into the air. In the UniWave 200, the movement of waves through the device's central chamber moves air through a turbine, causing it to spin and generate electricity.
We've been generating electricity from our wave energy converter since June of 2021. The unit has been in place on King Island for over 18 months.
How successful was the UniWave 200? Let's look at some numbers. First, efficiency. How much wave energy was the UniWave 200 able to convert into electrical energy?
Nearly 50% conversion of the energy that is coming into the unit in waves is being exported as electricity to the grid on King Island.
For comparison, the theoretical maximum efficiency of wind energy is about 59%, with most turbines extracting approximately 50% wind energy, according to a 2021 energy fact sheet from the University of Michigan's Center for Sustainable Systems. For solar, most commercial panels get between 15 to 20% efficiency, though researchers have developed some panels that can get closer to 50%. The other key measurement is availability. What percent of the time was the UniWave 200 able to convert wave energy into electricity? Wind and solar have both been shown to be capable of getting more than 90% availability, depending on the technology and how it's calculated.
We achieved better than 80% availability through the course of the trial. Whilst we know we can do better than that, and we will do better than that, of course, unashamedly, this demonstration of the technology was just that. It was a pilot and demonstration. There were many instances where we had interruptions due to the nature of experimenting and testing and fine-tuning, but we're very pleased that we've achieved that level of availability.
The one-year trial was also an opportunity to study the environmental effects of the UniWave 200 on the surrounding ocean ecosystem.
You can't help but notice the amount of sea life that is attracted to the unit. We're very confident that the unit has become something of an amusement park for sea life because we have no moving parts in the water, and we don't have lubricants and synthetic product on the unit. Then no materials entering the ocean that of a contaminant nature or otherwise.
Paul tells me the King Island location wasn't chosen for its ability to produce large volumes of electricity, but rather its diversity of ocean conditions. Now that the UniWave 200 has survived a year in these conditions, efforts are underway to bring the technology toward commercialization.
We'll have some very important objectives moving forward, getting more wave energy into the unit, how we think about the turbine and fine-tuning the turbine, and also opportunities within the column itself to think about, again, extracting more pressure and more air. So we certainly think that we have a roadmap to 95 to 100% availability of the unit. How we can rapidly reduce the cost of building these units, particularly when you're building them at scale. The ability to introduce more and more remote control capability of the unit and implement a great deal more autonomous functionality on the unit.
Paul says he hopes the UniWave 200 could provide multiple benefits to low-lying island nations in particular.
From a pure electricity generation perspective, we bring a technology now that can actually provide a lower cost and clean renewable energy source to those communities. But also, again, if incorporated in a breakwater or seawall that is designed and required as infrastructure for that island environment to literally protect the island from rising sea level and coastal erosion, then our units actually perform that dual purpose. You also then bring a finance, or if you like, a revenue stream to what would otherwise be the very challenging sunk cost of that infrastructure.
What do you think of the UniWave 200? Are there other energy technologies you'd like to see us cover on What the Future? Let us know down in the comments. As always, thanks so much for watching. I'm your host, Jesse Orrell. See you next time with the fam.